The third Starship flight, occurring just 177 days after the last full flight, marked a significant milestone in SpaceX's pursuit of space exploration. This flight showcased notable advancements compared to previous attempts, including successful hot stage separation, booster re-entry, upper stage coast phase, and partial upper stage re-entry. Additionally, the mission included a range of tests related to future Starship operations. So, stay tuned as we talk about everything that happened during Starship's historic third test flight. As the countdown for the flight progressed, SpaceX confirmed that all systems were ready for launch, with minor concerns regarding the weather, particularly the wind. However, the launch proceeded smoothly, and at T-40 seconds, the water-cooled steel plate began releasing water in preparation for liftoff. At T+5 seconds, the 33 Raptor engines on the booster ignited, propelling the Starship into the air, clearing the launch pad completely by T+10 seconds. Throughout the ascent, all 33 Raptor engines continued to fire without any issues, as confirmed by the onboard cameras and telemetry data provided by SpaceX. At T+52 seconds, the Starship reached max Q, the point of maximum mechanical stress on the rocket, without any complications. Over the next 2 minutes, various camera angles captured the rocket's acceleration and ascent, providing stunning views from both the ground and the onboard cameras. At T+2 minutes and 44 seconds, the stage separation occurred, with all but 3 of the booster's Raptor engines shutting off. Simultaneously, the 6 upper stage engines ignited, preparing for the next phase of the mission. Just a few seconds later, at T+2 minutes and 50 seconds, the booster and upper stage separated, marking a significant milestone in the flight. After stage separation, the booster initiated its flip maneuver while the upper stage continued its ascent, accelerating and gaining altitude. This phase of the flight was critical, as previous attempts had encountered issues leading to the explosion of the first stage. However, this time, there was a different outcome. At T+2 minutes and 52 seconds, the engine graphic indicated that the 13-center Raptor engines on the Super Heavy booster reignited for the boost-back burn. Around 3 minutes into the flight, remarkable footage showed the booster in a horizontal position, with the upper stage continuing its trajectory toward insertion. Beginning at T+3 minutes and 40 seconds, the booster's 13 engines gradually shut off as part of the boost-back burn shutdown process. Additionally, significant venting was observed from the bottom of the booster during this phase. Over the next few minutes, the upper stage continued firing its engines while the booster transitioned to a vertical position in preparation for re-entry. At T+6 minutes and 36 seconds, the booster entered the transonic phase, descending toward the ground and encountering the Earth's atmosphere. During this phase, the booster utilized its 4 grid fins to control its orientation and angle. According to SpaceX's flight profile, the booster's landing burn startup was scheduled to occur precisely at T+6 minutes and 46 seconds. As the booster continued its descent, the engines were intended to slow its velocity for a gradual splashdown in the Gulf. However, around 18 seconds before the planned landing, the footage showed the booster starting to oscillate back and forth as the grid fins worked to maintain its orientation. Shortly thereafter, there appeared to be a possible explosion, and communication with the booster was lost. Before the apparent anomaly, the engine graphic indicated that only 3 engines were still ignited, 1 in the central position and 2 in the middle engine ring. However, the 2 engines in the middle ring were only lit for a brief moment before extinguishing. Despite the ongoing events with the booster, the upper stage continued to accelerate. At T+8 minutes and 35 seconds, 6 engines were shut off, while the upper stage reached an altitude of 150 kilometers and was traveling at a velocity of more than 26,000 kilometers per hour. Around 12 minutes into the flight, SpaceX had a few in-flight tests planned. At T+11 minutes and 58 seconds, flight controllers announced the opening of the payload door on Starship. This door, although relatively small and thin, was a critical component that SpaceX wanted to test. A camera inside the upper stage showed the payload door closing later in the flight. Approximately 24 minutes into the mission, SpaceX attempted a propellant transfer demonstration. The success of these tests will require further analysis by SpaceX, and details will be released to the public in due course. One of the final milestones of the mission was a Raptor engine relight and re-entry. SpaceX clarified that the relight was not a deorbit burn. Rather, it was intended to demonstrate the capability to relight the engine in space under microgravity conditions. However, SpaceX decided to skip this burn and proceed directly to re-entry. Around 43 minutes into the flight, SpaceX provided a live feed from the upper stage, including onboard cameras, which provided viewers with unique perspectives of the ongoing mission. In the final minutes of the mission, as the vehicle approached re-entry, viewers could observe the fins adjusting as the spacecraft got closer to re-entering the Earth's atmosphere. There were moments when debris, resembling heat shield tiles, appeared to be flying off. For instance, 45 minutes into the flight, a significant number of tiles could be seen, accompanied by a reaction from the live SpaceX audience. Just past T+46 minutes, signs of heating on the fins and the spacecraft became evident as re-entry commenced. It's noteworthy that the movement of the upper stage and its fins during this phase hinted at a possible issue with the vehicle's attitude control and overall orientation, which seemed to intensify during re-entry. By T+47 minutes and 14 seconds, the live feed provided remarkable views of the spacecraft and plasma forming around it. However, just before the 49-minute mark, the video feed was abruptly cut, indicating a loss of signal. At that point, the vehicle was still in the process of re-entering the Earth's atmosphere. Following the scheduled entry at T+49 minutes, Starship was expected to make contact with the water approximately 15 minutes later. However, after the video feed was cut, SpaceX faced uncertainty regarding the status of the vehicle. Initially, they noted the loss of connection with the tracking and data relay satellite system and Starlink simultaneously, indicating a potential breakup of the vehicle during re-entry. Subsequently, SpaceX confirmed the loss of Ship 28 during re-entry. Based on the footage leading up to re-entry, which showed heat shield tiles and debris, it's plausible that the ship lost a significant number of tiles before entering the atmosphere, creating a potential weak point leading to its breakup. Additionally, there could have been issues with the angle and exact orientation of Ship 28, which are crucial factors for a successful re-entry. Had the vehicle survived re-entry, it would have continued on its trajectory and impacted the ocean. Overall, SpaceX considered the launch a massive success compared to previous flights. In the previous attempt, the booster was destroyed soon after stage separation, while the upper stage encountered issues with engine shutdown. This time, the booster made it almost all the way to the ground, and the ship partially completed re-entry. Additionally, several tests were successfully conducted during the flight, providing valuable real-flight data for future Starship prototypes and launch attempts. SpaceX emphasized the importance of iterative development, stating that the third flight test aimed to build upon lessons learned from previous flights while tackling ambitious objectives. This approach, characterized by rapid iteration, has been fundamental to SpaceX's major innovations, including Falcon, Dragon, and Starlink. They highlighted the necessity of continuous improvement as they strive to develop a fully reusable transportation system capable of carrying crew and cargo to Earth orbit, facilitating humanity's return to the Moon, and eventually enabling travel to Mars and beyond. With the successful completion of this test and promising results, SpaceX anticipates conducting a fourth flight test relatively soon. To provide context, the time between the first test flight and the second was 212 days, while the interval between the second flight and the recent launch was only 117 days. These improvements should streamline the approval process and launch preparations for the next test. In terms of hardware, SpaceX announced just over a month ago, on February 2nd, that they have secured Super Heavy boosters for the next 3 flights, with a 4th being prepared as a stack in the Starbase Mega Bay. This indicates that they have the necessary hardware to continue flying the vehicle at a rapid pace. In the aftermath of this test, SpaceX will release more information in the coming days and weeks. Teams will be diligently analyzing all aspects of the flight, identifying areas of success and areas for improvement, and implementing necessary fixes. These efforts will pave the way for further advancements in the coming months. Please make sure to subscribe to our channel to keep up with the latest updates about the Starship and its eventual mission to Mars.